Hello, this is David Hawkins with Prairie Design Build. I'm the lead building scientist on staff here, and we are at the Lake Quivira Retrofit Passive House project, and we are in Lake Quivira, Kansas, just outside of the Kansas City metro area. We will be conducting a blower door test to initially see how leaky and where all the leaks are in the building envelope, and exactly how much work we got cut out for us here. Come on in. Set up the blower door test in one of the main entryways of the home. There's a couple of components to the pieces of equipment. We have the industrial sized fan, the frame in which the fan sits inside, and a little computer that we're able to control the fan and measure Pascal differences. There are two portions to the test. There's a pressurization where the fan will blow air into the home and air will leak through all the windows to the exterior side and all the openings that are in the envelope. And then there's a depressurization where we flip the fan around and the fan will suck air out of the home and air will come through from the outside to the inside, all the openings in the envelope. We changed the pressure from positive 75 pascals to negative 75 pascals, and we take readings of how much air movement, of volume, that the fan is actually moving. The house is at a depressurization state. So all the air is getting sucked into the house and blown out the blower door. And we're going around all the spots and just kind of feeling how bad this 50-year-old house is. And it's hard to put it into words, so as a demonstration, this is a leak. So there's a leak around a door. And there are several doors in this house, and as you can see, there's a huge amount of air that's coming in at a very fast rate. Here we are in the living room portion, still under a depressurization test right now, and the amount of air that's coming in through around the window frames is phenomenal. A room like this is basically a piece of Swiss cheese at the moment, and these registers, and we've turned off the heating and cooling system, are still blowing a ton of air into the home. This is all because the heating and cooling system's down inside the crawl space below and allowing a lot of air circulation. So we're not really controlling any sort of the air movement at all. These electrical outlets are also a very common source of air leakage, and you can feel that they're blowing at a nice little rate. Fireplace here, you can feel right along this grill surface how much air is coming through. Wow, that's kind of crazy. That's testable right there. So, as you can see how fast a bag like this inflates, that's a tremendous amount of air leakage. The results are in from the blower door test, and we measure it in ACH, or air changes per hour, at 50 pascals. Unfortunately, our test could not even get up to 50 pascals worth of pressure difference because of how leaky this home actually is. We estimate it to be around 15 air changes per hour at 50 pascals, and passive house is at 0.6. So we got a lot of work to do around this retrofit project to try to button up this envelope so we can get anywhere close to a 0.6.